Hello, this is Kimon Onuma. I'm an architect, and we also develop our own applications in the cloud. And I created the BIM Storm years ago, which I will be talking about. I'm really happy to be here to talk about BIMin and it's a tongue twister, BIMin and Twinin. It was intentionally a tongue twister just to play on the words a little bit. But I'm excited to be talking about this today. So I've had a long journey, and ours is a little bit unusual because we are architects that use the tools, but we also build our own applications and we consult with owners on their strategy, whether they're using our application or not. And we've been doing this for over 30 years. 15 years ago, we started something called BIMstorm. This was the first BIMstorm 15 years ago, called BIMstorm LAX, and Catalyst called it the Summer of BIM. It was a 24-hour live event on the web with hundreds of participants from around the world. And the reason we did this is we wanted to explore how we can collaborate, regardless of what application you're using, regardless of what technology capability you have, regardless if you know BIM or not, because there's all kinds of stakeholders typically involved, as we know, in complex projects like this. We had participants from around the world, and it was kind of ad hoc. We said, just jump in. Here's a scenario. We put it on the web. We had Google Earth going. We had all kinds of BIM applications and analysis tools going. We learned a lot ourselves, which is one of the reasons we even did this. We want to stimulate thoughts and discussions, and we want to stimulate collaboration, and we want to look at it actually even building applications ourselves, because we as architects have always thought this, that yeah, there are great tools out there, but there's obviously more that you can do if you can actually tweak things, and that's been our passion from the very beginning. At the end of this 24-hour event, and while we were doing this, we were preparing material to submit for an award, American Institute of Architects Award. So it was all real time, 24 hours, boom, 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 submit. The deadline for submittal was when we finished this. So we just hit the submit button, submitted, and we won an award for this. And we've had many, many BIM storms after that, including this one for Japan. We look at different events around the world, and we had the tsunami in Japan. We had different teams that were actually sending material to Japan on these planes from the US housing, and we had teams looking at GIS and flood areas. So it's all these different pieces coming together. And that's what I think of as a digital twin really is, how do you look at information and collaborate cross-platform, cross-stakeholders, regardless of what tools you're using. And this was an event that probably lasted about a week. I can't remember exactly the time frame, but it was another BIM storm for Japan. And we've had close to 40 BIM storms, I believe now. Another one was called Planes, Trains, and Automobiles, and BIM. We wanted to look at logistics for an airport, and logistics because it was interesting because planes are like big buildings. They move around. There's people move around. It's a constant motion. So buildings are often looked at as being relatively static, but we know they're not. Even a static building is really not static. Everything is moving. But an airport is an extreme example of things changing, and witnessing what happened with COVID too. Everything shuts down for a few years. What do you do? This was pre-COVID, but we set up a scenario using the San Jose Airport in California. We had many participants from around the world. And some of the scenarios were obviously planning and designing an airport, but there was also kind of a logistical thing of how do you even define the requirements? What drives a need for an airport? And we know as architects and planners that, yeah, planes, size of planes, things like that. From the very beginning, from 30 years ago, we were always fascinated with what's the driver for why you build, and how do you capture those drivers of why you build, and how do you adjust the requirements? And there's obviously millions of data points. And traditionally, this has all been done with static documents and Excel files. And I know BIM can do a lot more today, but this was starting from 30 years ago. How do we capture those logistical requirements in objects and assets, whether it's a building, a plane, a chair, a person? And we have this site called Program to BIM, which we set up for our clients as well, but it's open to the public where you can actually go in and build a BIM just by almost like an Amazon shopping cart. I want 3 of these planes, 2 of these waiting areas, and it kind of assembles the requirements with the associated data behind it in the cloud that then can be pulled into different applications for analysis from the very early stages. And that was always a goal of ours, was how do we move that BIM hump early and earlier on to simulate these kind of what ifs and then get input from different stakeholders. So here's a simple example of what was assembled on the web as a clinic requirement for a 4,000 square foot clinic. And as soon as you start assembling these pieces, you can start moving them around or analyzing the energy use. And this is before any design even really starts. It's kind of the assembly of the data that goes into the communication, and then confirming we're on the right path before you have a train wreck. It's really kind of simulating the train wrecks early on. So this is a screenshot. There was a lot of things happening in this BIM storm, but there were a lot of different participants: the Asset Leadership Network, Giuliani Associates, architects, engineers, builders, developers, logistics people. And we started running through scenarios. Okay, here are the pieces that we need for this airport. This is one example. How many planes, how many waiting areas, how much this, how much that. Okay, you have all the pieces in place. Then say, okay, what if we have data that shows a plane's actual movement? And that's obviously real-time data that says, well, here comes a plane, it's going to land here, and there's another plane in the way because it arrived an hour early. All these logistical things that drive how do you design an airport terminal, and how do you optimize that, and how do you account for changes in schedules, changes in planes. A lot of moving parts. It was really exciting because we really kind of pushed the limits on this. And gate scheduling impacted layouts. So we said, what if you change the scheduling and become more optimal at this part of the day when you have a surge in the morning and a surge in the afternoon? In San Jose, for this case, it was an airport that has a lot of morning and afternoon traffic and not much happening in the middle. So we wanted to look at scenarios like that. So just one small example of that. Then Ukraine. Through the Asset Leadership Network, we were connected in a BIM storm where we had logistical people on the ground there that were managing port facilities and movement of equipment and energy systems, portable microgrids, actually. How do you set up microgrids on the fly in different scenarios in Ukraine, actual things that were happening on the ground there. So through the web and through the BIM storm, we were able to do that. In the background of all this, we are using our applications, but we're also collaborating with other consultants and vendors that use their own applications. So YC&D has their own system for modular design, and they were involved with the Ukraine BIM storm of how to set up modular construction and respond quickly to requirements. So it's really about pushing the limits and connecting the dots between different stakeholders. And that has always been the pattern for us. And what's interesting about all this for me personally is that it helps me learn and my team learn new things. It challenges us as well as challenges the industry. And being transparent about this is not usually easy to do in an actual project. So BIM storm is kind of set up off to the side. Real things are happening. And in fact, we've used BIM storms for actual projects as well too. But when you move it out of the environment of now you have a contract, now you have to compete, now you have to sell your software, it opens up the world. And then we can learn from that and apply it to our actual projects, our actual software development, our actual collaboration with owners. And owners are looking in on this and saying, wow, can we do this for A, B, and C? We have the same use case. And that is one of the outcomes of these BIM storms, is that we learn and we apply it to different projects, actually. At the same time, we have our own application. A little plug for our system. It's called the Onuma system in BIM Genie. We have a web application and it connects to other tools. And we have BIM Genie, a work order and preventive maintenance CMS system. And we have an API in the background. So as we're putting data in, we're saying we're not putting it in a black box. We have an API so others can plug into it and use that data and collaborate with us. We flipped the whole model around. This happened years ago. And a lot of people were telling us we were crazy when we first started this, maybe 15, 20 years ago when we first went down this path, is you have your application, just lock things up there and get people to buy your tool. Okay, that's great. But that doesn't really solve the need of the digital twin or the BIM or the common data environment, whatever we call it. It's really about the connectivity. And so these APIs that we use are tools for ourselves, but also tools for other collaborators to work with. And they've also been used over and over again as a model for other owners that we work with to develop their own internal systems, to open up the black boxes that typically exist in the industry that are really holding us back. And it's unevenly spread, this whole future thing, that quote from William Gibson. But it really, there's a lot of amazing things happening, and there's a lot of really stupid things happening, and everything in the middle. And we're hoping to move it faster towards more collaboration, more efficiency, more transparency. And transparency doesn't mean free for all. That's another important part of this, is that it's opening your data, but not, you can still control it. But if you default to we can't share anything, then yeah, you're not going to share anything, and you're trapped in a single vendor's application or your own black box, whatever. So early on as an architect, I looked at documents like this, schedules, and I said, wow, this is really data. And this aha moment came to us over 30 years ago when we first started. We were using CAD and data and tables and whatever, but we quickly moved into databases. And we said everything that we do as architects, it's about collecting information, organizing it, and creating the relationship. This door belongs to that space belongs to this, that piece of equipment has this attribute. All of that stuff that we've been doing forever on paper is essentially a massive digital twin. It's a massive database. It's just in an analog format. So using the same logic, the architecture of buildings fits into the architecture of the digital world and digital twins and BIM. And that has been our method all along. How do we take all of this stuff and translate and repeat it? Another very important point, and one that we caught on to early on ourselves, is do not be distracted by shiny objects. We love shiny objects. We love BIM. We love 3D. We love VR. All that stuff is great and we use it. But it also can be very distracting, because if you focus on that, wow, we're going to have an amazing digital twin that you walk through and do this and click on it. And yes, that's happening and that's going to be the future. But you lose focus on the simple things. And the simple things are things that have a huge value as a foundation to do all the amazing things. So for example, if you are an owner and you can't even describe what you want in your hospital, and you give an architect a stack of documents and a stack of meetings and say, what do we need in this operating room, blah, blah, blah. That happens over and over again. Now the architect says, okay, we're going to put it all in BIM. We're going to take your information that is in this crappy format, convert it, transform it, and put it into our BIM, into our digital twin, into our single application. And we're going to do amazing things with it. And that is happening. But if we focus too much on the shiny objects, we get sold on shiny objects over and over again. And that's a frustration. Yes, there are amazing tools out there. And I can say this as an architect and a software developer, is we bought those shiny tools and we still use a lot of those shiny tools, but we also want control of our information, and we want the ability to divorce ourselves from the applications, to say, yes, we like your application, but we want to use other tools and we want to connect other little apps that do an analysis on this, or we want to connect an AI system that looks through tons of data and gives us some kind of interesting result. The only way to do that is to be able to divorce yourself from the application, decouple the data from the application, and be able to create your own application, and to be able to work with others that have other interesting applications. So from 30 years ago, we started down this path of BIM, and we started with CAD, and we started with 3D, and we started with databases that weren't connected to it. And then we quickly in the early 90s got into BIM, first with ArchiCAD actually, and we still use ArchiCAD as well too, and Revit and all the other ones. That we are not stuck to one. But the aha moment, even 30 years ago, is the first inclination when we got into this 1993 model of a US Navy base. It was too big to do in ArchiCAD. That's what they told us, but we did it anyway. Thousands of buildings and facilities, a huge master planning model. And we said, let's put all the data in the model. Well, yeah, that works, but all of a sudden the model gets very heavy, and you start to need to break things apart, because just from a technology point of view, it was impossible to do, but also from a logistical point of view, it didn't make sense. And from that point on, we constantly are looking for how to decouple and move things away from the center and connect other things. And this kept on going with the U.S. Coast Guard, and we had BIM bombs with them. And then we had the BIM and GIS connection in 2006 with Open Geospatial Consortium, and it moved on from there. So everything started connecting together: BIM, GIS, CAD, databases, CMS systems, platforms. And that was really our journey. And the fact that we know the technology side and we can give those kind of recommendations, and we know how to build our own applications, allowed us to do things like with the US Coast Guard. We said, okay, you have assets, ships that drive the need for buildings. Okay, we can focus on a BIM about a single building, but it's about your whole supply and demand infrastructure. How do these assets drive the need for facilities? How do you react to and build those? And the only way to do that is to break away from the single building, single BIM, and look at, okay, how about GIS? How about your other databases and systems? What happens if your demand changes? 9/11 comes around and everything changes about what kind of buildings you need to support your mission as a Homeland Security for Homeland Security. So that was an early 2000 view. California, that's where we're located. I'm going to talk a little bit about what's happening in California with BIMin and Twinin. The California Community College is one of the largest, if not the largest, community college district in the world. They have 2.75 million students statewide, 90 million square feet, 112 locations. They have a system called Fusion that has their facility data. We had our system. We said, what if we take your Fusion data that you have in your database and connect it to shapes on a map or shapes in a building? We didn't even call it BIM. It is BIM, but it was too complicated to explain BIM a lot of times. So we said, okay, you have data, we have a graphical interface, let's connect the two. And the way we connect it to, a typical vendor would say, you have data, a lot of data, give me your data, we'll put it in our system, throw away your old system, and you'll buy our system. Well, that's just fine, and it still works in many cases, but it doesn't scale. So we said, no, you have data on a SQL server. We're going to teach you how to set up that SQL server so you move it out of that black box. So you give us a plug so we can plug into your data. You maintain your data. We'll start doing things with it that is valuable and useful to your end users. Some of the end users are facility people, some of their designers and planners. So over the years from 2011, this is over 10 years ago now, we started helping them as an owner. And this was not even asked of us, actually. We just kind of pointed them in the right direction, and it turned into other projects from that. And then the whole state, basically we have the entire inventory of spaces because it's their data, but we plugged into it and we view it in our systems, and we can do stuff with it. We can do stuff like, oh, here's one building out of the 5,000 that's coming in as a new construction. We can guide that AEC team to deliver their asset data in an open format like Kobe that flows into their BIM, but also flows into this owner's asset inventory that's important for their operations and maintenance. And this is basically the architecture. It's like Legos. You said, you have your Fusion data. We'll teach you how to open a SQL Server API into that. We'll also open up your GIS data. You have other districts, LA Community College District, which we've been working for over a decade too, but over the last few years, we've been building up a lot more functionality for them that have their own BIM and CAD inventory. We built that red box, said, let's build an API, connect all these Legos together, connect our server, our BIM server on the system to that, use your data from below, and then build other Legos on top. Here comes BIM Genie, which is a work order preventive maintenance system, Dabblefox, which is a custodial system, and there are other future systems and apps coming into play. The reason this architecture is important, because if the Legos above disappear or change or whatever, the underlying data still stays stable. The twin of the owner is their data, and the applications are disposable, including our application. And all kind of visualize in apps. We had to make it simple so the end user can see it and do stuff with it. Complex data in a simple format has always been our focus. How do we make that happen? And for the LA Community College District, they have 1,100 acres, a huge district, again, the biggest one in the state. Out of the 5,000 buildings statewide, they have 742 buildings. Within a few months, they've been trying for many years, actually, to have a CMS system connected to BIM, and they were failing because it was too complex, in my opinion. They were trying to do too much and promise too much in many ways. And we said, let's keep it simple. Let's get to the data that you already have in the Fusion system that I mentioned earlier, connect our system. And within a month, we had them up and running within a month for their entire inventory in BIM and CAD, and with a CAD input in some cases, with GIS data, all linked live. So if data changes at the state level, they see the room number or the information of the building changes. If their data changes at the city level for the community college in the LA city, then it gets layered on top. And all this gets stacked together, all the stuff, the back end data doesn't matter where it's coming from. The front end user saying, I can see my building and I can make decisions with that. This would happen in the last few years. We've been going for 2 years now, but it was implemented, the first version, in a month. So what's the takeaway here? There are proprietary islands. We all know this challenge that we have. We want to connect with standards. There are standards, but standards, a lot of them are used kind of to import and export from one system to the next, which is fantastic, but that's just the beginning. If we think in terms of a platform of sharing data like those Legos, then you can get the data flowing up into different users, regardless of what application you're using. And the demand now is for mobile interfaces, no training tools, being able to have this BIMin and Twinin Galaxy to be able to do whatever you want in space or on Earth. And this is part of the ecosystem that we want to all be in. The National Institute of Building Sciences, we are working with many owners that want to connect their portfolio and projects, and architects and engineers are in the middle, and we're doing consulting work. They're not even, a lot of the owners that we work with do not use our application, but use our strategy. So everything that I showed you before, essentially we're applying those to owners through these projects like healthcare. Same thing. Catalog your information for spaces, use that for BIM design and construction, put data in the cloud, build an API. The formula is pretty much the same. Decouple your data, make it accessible, make it neutral, then use all the amazing shiny object tools that are out there to do stuff, to be able to connect your design, construction, programming, projects to operations. A lot of owners want to get to BIM and facilities. Okay, that's great, but you need to have some kind of structure in the beginning. Simple structure, it doesn't have to be complex. What do you design, build to get to that? Another owner that we've been working with for the last over 5 years now is the U.S. Department of State Bureau of Overseas Buildings Operations. They have a huge inventory, very complex project, a lot of security issues, a lot of sharing requirements. They looked at what was going on with the NIBS project for healthcare and said, can we do the same thing? We need to go through planning, design, construction, operations, connect all the dots, use a lot of different tools, a lot of people that don't care about BIM but want to get to the BIM data, all stuff like that. Same formula. So we said, okay, let's start with your internal standards. Let's establish what used to be in PDFs and scattered in many different Excel files, basic stuff. What do you call people? What do you call spaces? What do you call stuff inside spaces, assets? Build a database of that and then drive it into the design and construction. Drive it into planning. The data drives into BIM. The BIM then uses the same standard and gets delivered back to the owner. That's the formula. If the owners don't ask for it in the right way, they're going to get all kinds of different formats and they will not get to the end result that they want. And then work with the architects at different stages and be very methodical about cataloging and capturing processes and being able to communicate internally and externally of how you want to make that work. The end result is that data becomes an asset for many stakeholders. The assets can be used regardless of if you're using BIM or digital twins or common data environments. It doesn't matter what you call it. I just want to get to my app, find out how my project's doing. I just want to get to my app and find out how much we're spending on assets, on equipment, whatever. I want to get to my app and see how we're going to plan on reducing energy. I want to get to my app and see how my whole portfolio is doing. Very different questions. Or I want to get to my app, I'm going to fix this equipment that's falling apart. Many different stakeholders, many different views, many different applications on a common platform, not a single platform. That's the important point. It's not a single platform. It's not a single tool. It's many tools, many stakeholders. A version of this is in the Irish Buildings magazine for the BIM Coordinators Summit in 2022. I'm very happy to have been invited to present and to write about this. And I would like to end this with asking if there are any questions. We could take questions now. I know I went pretty quickly, but thank you for listening and talk to you soon.